Hello everybody and welcome back. Root Beer here, and we're going to continue our look at hyperbolic geometry. Now before I get to making nice things like perpendicular lines and angle bisectors and things like that, I thought I'd talk about one of the biggest changes people notice between hyperbolic geometry, which we have geometry in the disk, and plane geometry, Euclidean geometry, the one that we tend to be very familiar with, used to. So the biggest change is angles, how they look, how they measure. So we could, using our brand new hyperbolic straightedge or hyperbolic line tool, we could actually make a hyperbolic triangle. But this doesn't look like your ordinary triangle. I think one of the first things I'll do is make a hyperbolic line segment tool. I'll deal with that eventually. But what am I trying to say here? Look at this triangle that we've got here, this hyperbolic triangle. It's not readily apparent how the angles stack up. Is this a right angle down here? Are these angles acute? And this is what I mean by saying angles are the biggest change people tend to notice. How do we even talk about angles? Well, to talk about angles, at least in our disk model, we're going to have to bring back the tangency tool. And I'll make it orange just so it's more apparent as to what's going on. So, just get rid of this line right here. So we have an angle here between two hyperbolic lines. How do we measure that angle? Well, we get out our tangency tool, and tangent to this arc, we draw a tangent line through that point, the point intersection of our hyperbolic lines. And through this arc, we get ourselves another tangent, again to the point that is the intersection of our two hyperbolic lines. It is the angle between the two orange lines, standard angle measured with like a protractor in Euclidean space, normal way. That is the angle that we assign to the angle between our two green hyperbolic lines. Okay, and this makes a sort of sense. I mean, you might say, well, geez, when we look out here, the green lines are much further away than the orange lines. How can the angle be equal? But if we zoom in and zoom in and zoom in, we notice the tangent lines and the green circular arcs, they basically become indistinguishable. Okay? So it is sort of in this sense that these guys are the same angle. That in sort of the limiting case as we approach the point of tangency, we do indeed get the same angle. Okay? And then you get other things like the sum of the angles inside a triangle is not 180 degrees. It's always less than or equal to 180 degrees. And, there's other fun triangle things. Did I say some of the angles inside a triangle, or did I say some of the angles inside a circle? This is what happens when you don't work off a script. Some of the angles inside a triangle is always less than 180 degrees. And another interesting triangle fact is that if your triangles are similar, they must be congruent. Whereas we know in Euclidean geometry, outside the disk, with regular, one parallel line through a point to another given line sort of geometry, the one we're all familiar with, you can have similar triangles that are not congruent. You can have a triangle that's big and scaled up as opposed to a smaller one. This is not the case with hyperbolic geometry. Okay? So I just wanted to talk a bit about these angles before we actually got into the constructions. And the constructions we're going to do with the hyperbolic straightedge and compass that we have are actually fairly similar to the ones that we have done, or if you've watched my Euclidean straightedge and compass series. Okay? But I think in the next few videos I'm going to show how to you're going to construct a new segment tool. Maybe I'll do rays, although GeoGebra is a little finicky about rays, hyperbolic rays I've found occasionally. But we'll do angle bisector, perpendicular bisector, perpendicular line. We'll even construct some parallel lines, which I think is the most interesting thing. Because it's hyperbolic geometry, we get it by assuming that there's more than one parallel line, although I don't think I can make the infinite parallel line thing a tool. But we'll see. So, that's all that's coming up, but I just want to talk about angles very briefly. So, thanks for watching, and join me for more hyperbolic geometry in the next video.